Hey team, I'm Maddie, welcome to Science Side Up, and today we're talking about entropy. Entropy tells us how much energy in a system is unavailable to do work. Another completely valid definition is that entropy is a measure of the amount of chaos or disorder of a system. But just between you and me, if I asked you, hey you, what's entropy? And you told me a measure of the disorder of a system, I would probably say, cool. But what is it? So what we're gonna do today is we're going to go through a super simple physics problem and use that to kind of get a physical intuition for what entropy really is. The physics problem we're gonna consider is this. Suppose you have a block at the top of a ramp that is at rest. That block is then allowed to slide down the ramp, and we want to know how fast is it moving once it gets to the base. To do this problem, we're gonna think in terms of conservation of energy. We've got two forms of energy going on here. One, gravitational potential energy, right? This guy is up at the top of a ramp. He has some gravitational potential energy, mgh, mass times acceleration due to gravity times height above the ground. And then when we start to move, we've got some kinetic energy, 1/2 mv squared, right? So that's what we're gonna consider. We're gonna consider the exchange of energy between potential energy and kinetic energy. Two parts of this problem are gonna simplify things a lot. One, I said that the block is initially at rest. So velocity at point A is 0, meaning that whole term goes to 0 and we get to ignore it. And then two, when we get down to the ground, my height above the ground is 0. So this guy goes away and we get to ignore it. Which means our problem reduces to this. The velocity at point B when I'm at the base of the ramp is just the square root of 2 times acceleration due to gravity times the height. For a height of 1 meter and acceleration due to gravity of 9.8 meters per second squared, this is going to give us about 4.4 meters per second. Huzzah! Now let's say that we did this as an experiment and we actually went in and measured the speed of the block at the base of the ramp. And let's say that what we found that speed to be was that it was actually going only 4 meters per second, not 4.4. The question there would be, did we do something wrong? Where did that energy go? Because if my actual speed is slower than what it should be, that means my actual kinetic energy is less than what it should be. I can't put any energy into potential energy because that height is still 0. So where did that other energy go? Well, the physical answer is that there's always some friction here. So it was lost to friction, but friction is a force, not an energy. So how in the world would we represent that as an energy? And that answer is entropy. The entropy of this system is going to be how much of this initial potential energy wasn't converted into speed, wasn't converted into kinetic energy, or how much energy was lost to friction. And when I say lost, I don't mean that it actually went away. We just couldn't use it to move the block. So if I wanted to correct my original equation, I would need to add a plus delta S on the right-hand side. I almost left myself enough room for that. S is typically the letter that we use in thermodynamics to represent entropy. And if you're doing an energy balance equation, we could do entropy on side A and entropy on side B, but usually what we're interested in is going to be the change in entropy from the start to the end state. So a delta S, or change in entropy, is usually more useful. So this also tells me something very important about entropy, and that's entropy has units of energy. So that's going to be joules or ergs. Entropy is just a form of energy, but it's a form of energy that we can't harness to do work. I hope that made sense to you guys. Once I understood entropy in this like physics 1 context, it made a lot more sense to me. So I hope that's helpful, because discussions of entropy can get real philosophical real fast, and no offense to my philosophical friends, but that is not how my brain is wired, and I just want that more tangible aspect. Okay team, that's all I've got for you today. I hope you liked this video, and I will see you all in the next one. Bye team!